Yeah, Sumit, you can go ahead, please.
Okay, so just one moment. Okay, so Pawan, hello, my name is Sumit, and can you just introduce to yourself a little bit about your, technical expertise and current organization you're working?
Yeah, sure. Myself, Pavan, and I'm pursuing my master's in USA and in
Okay,
NPU, California. But I was not an expert in any of those because I was just a beginner and I just came after my graduation in BTech in Vizag, Geetham.
okay, so
Uh,
that's
uh,
perfect. Okay,
I don't have any work experience, but uh,
and all
okay.
right, fine. There's no problem. And what about Linux? Have you worked before on Linux operating system?
I do have some expertise on Linux, but
Uh,
not on completely. I just know the commands of how to go to directories and how to do the stuff over there, how to make files, how to run them, like that type of things. Because in my college, I'm a teaching assistant for Unix Linux network programming. I just have a basic idea about it.
okay.
I'm not depth into it, but I know what it is.
All right, fine, no problem. So, okay, and so first of all I'll show you how that OpenStack dashboard look like. So, my screen is visible to you. I think so. I think right. You can share my.
Yeah,
You
I
can see.
can. Yeah,
Okay, fine.
I took
So
it.
when we install, okay, fine. So when we install
Uh, uh,
OpenStack, so this is a OpenStack
One
Zuno
second.
release. Mm-hmm.
Oh, 1 second. Sumit, sorry that I don't know anything about OpenStack. Can you come with a brief explanation of what it is and
Yeah,
how it is
definitely.
used, and
Yeah,
then we
yeah,
can.
yeah, yeah. First of all, and what is the, why we use, first of all, what is the requirement,
Okay.
why we require the OpenStack. Okay, so first of all, let's talk about our traditional data center. I mean, I have around 5 years of experience in Linux virtualization and almost from last 3 years I'm working on cloud technology as well. So when I started my career, so I started in a data center. So the traditional work in a data center is like when we have a physical machines, we have switches, physical switches and physical routers. So suppose any business requirement comes to the operations team, so that is gonna that always take a use time if we want to deploy a certain applications, certain operating systems on a physical system, as well as we need to look into that vendor specific documentation if you want to install the operating system configurations. So this was the traditional work we were doing in a data center. After that, virtualization technology came up. So in the virtualization technology, definitely we can host a number of VMs on a physical host, single physical host. So basically, there are different kind of virtualization technology. Measure the virtualization. There's a hypervisor type. So basically, in the virtualization, there's a product. We can call it hypervisor. So it's a kind of product category we can say. So hypervisor actually plays a main role into the virtualization. So the hypervisor actually basically there are two types of virtualization. First is the type 1 virtualization that we call bare metal virtualization, and there is a second is here you can see is a hypervisor tab. So okay, so I'll explain you what exactly it is, what exactly is showing. So there is a type 1 and type 2 virtualization in the market. So type 1 is basically that we use in the production environment. So type 1 is basically bare metal virtualization where there's a, we can say, I can show you just one moment. I think I do have a document for you. Yeah. So Linux, the default virtualization is a KVM. KVM is a kernel virtual machine. So there's a different virtualization are available in the market. There's a VMware. They are pioneered in the virtualization technology. The Hyper-V, that is a Microsoft virtualization product. There's a Zen server. So actually Zen was open source, but later in around I think 2003 or 4, Citrix took the Zen open source community and they release enterprise release of Zen server. So latest Zen server 6.5 is the latest hypervisor, and there's another hypervisor which is KVM, and we will work on a KVM. So KVM is a kernel virtual machine that, and KVM is basically provides both kind of functionalities, a type 1 and type 2 virtualization. So this is these are major products in the virtualization technology. VMware, KVM, Instance Server, and Hyper-V. So let's talk about the types of virtualization. I can show you the difference. Definitely we'll go in depth. Okay, so here is type 1. Type 1 basically bare metal virtualization. If you can see here, so we have a physical hardware. On top of that, we directly install the virtualization, and on top of a virtualization layer, we create a virtual machine. So this is basically type 1 virtualization. And however, in type 2 virtualization, we have a hardware. After that, host operating system, whether it's a Windows or Linux, and on top of that, we install a hypervisor. So that is a type 2 virtualization, and on top of that, we install a guest operating system. So we can say simply in, like, I can show probably I do have, yeah, this is a very, I mean, clear picture of the how the virtualization is. You can see here is a hardware. So basically, when we set up hardware, so hardware must have a support functionality for the virtualization. So for the Intel processor is a that technology called Intel VT. However, for the, if suppose the AMD processor, it's a AMD technology. So basically, in that we can check those hardware extension technology into the system hardware, and we can enable and disable it from the BIOS. So here you can see we have a physical machine. After that, on top of that, we have operating system, and top of that we have a KVM. So KVM is basically works a little bit in a different way. The functionality is same, and the basic concept of all the virtualization product is the same, but the KVM works very closely with the Linux kernel. However, the different virtualization like VMware or Zen, they need some modified kernel. However, it's not like that. And the KVM work very closely with the Linux kernel. So whatever the features, functionality, security we can get into the Linux operating system. Same features we can use with the KVM virtualization technology. So here is a hardware, virtual operating system, and that the KVM. On top of that, we create the VMs. You can see here. So basically, there is a on top of that when we create a VM, so it emulates the hardware. There is a when we go into the depth, so I'll explain you how exactly the emulation works, how that the physical hardware converts into the virtual hardware. So on top of that, we create a VM. So that is a basically virtualization type 1 and type 2 virtualization for the servers and desktop operating systems. Now, why is the cloud? First of all, so cloud basically provide more flexibility of the resource utilization. We can, whenever we want, we can horizontally, we can scale up the environment and down environment whenever in minutes. And first of all, the automation is very easy in cloud. Let's take example. Have you worked on application? Which application do you work? And in programming language, do you have any experience?
No, I don't have any experience in any application.
Okay. So usually when we deploy the application into production systems, so just I will give you an example, the basic how exactly that deployment works. So basically is development, after that UAT, then QA, then production. So in that scenario, so each and every team, development team, QA team, UAT team, they need resource availability as soon as possible. So they push pressure on the QA operations team that I want to operate VMs, I want to operating system to install my application, to test my applications. So definitely on the physical hardware is very difficult. If you procure a single hardware, the big cost is involved, and definitely then management approval is required. So that it always takes around minimum. It takes around 15 to 1 month, 15 days to 1 month. However, in a VMware or KVM virtualization or any virtualization technologies, we need a little bit expertise to handle the resources, to work how to create the VM, to manage the resources. But in the cloud is nothing we can say is a Gmail kind of application. This is a kind of example. Gmail is also cloud application, is a PaaS solution. So and we can say it's a different SaaS solution is there. So just user just log in into the portal. he can just check like Windows operating system. You can just see the menu. Okay, this is the button to create the VM. In minutes, in seconds, he can create the launch the VMs and he can work. So this is basically the fast provisioning of the resources on demand. Whenever want, we can delete. The automation is there, so we can create a number of VMs and thousands of VMs in the 1 hour in the virtualization. Why? Because of those resources are hardware independent. If suppose anything binded to the hardware, we cannot work faster. There always be the hardware is a bottleneck to make process faster. So like DevOps and automation. So if suppose every layer comes with the software layer, we can write a code, we can make things faster. So this is basically cloud. So basically the cloud is like there is a different kind of cloud solutions are there, like IaaS, infrastructure as a service. So in that we can manage entire data center and different data center resources, whether it's a network, router, firewall, and physical servers, VM, we can manage over the cloud for the users. And there's another kind of cloud model there, that is a PaaS. So PaaS is a platform as a service, and Amazon is a very good example of IaaS cloud. So basically in the IaaS cloud, what we do, we provide a solution to the customer. Whenever required, they can create their own network. Just click it, network will be created. They can create their own volume. It's a very, user-friendly environment. It's not like that they needed some very good expertise to create the virtual machine, to create the network. Not like that. The basic information they have, that's enough. Just click it, create the network. So basically in the cloud solution, we provide the environment to the customer end users, so they can, whenever they want, they can procure the resources. Then whenever they want, they can release the resources, and they have to pay whatever they use. If suppose they create a VM and they just powered on the VM for the 2 hours, and then so they have to pay only for the 2 hours resource utilization, whether it's a storage, whether it's a network, or whether it's a compute. If suppose the VM down, nothing to pay. So Amazon, AWS, Web Service is a very good example of the IaaS service. There other solutions are also there, like Rackspace also provide a IaaS cloud solution, and there is another cloud model that is called PaaS, platform as a service. So in that, basically the platform as a service, basically we can say is for the developers and the testers. So basically in the majorly that PaaS solution works on the containers and the VMs. So in the PaaS solution, the end users get very limited resource, and they cannot manage the network, they cannot manage the storage, they cannot manage the VM. However, nowadays the PaaS solution has that much of functionality. They can manage the VM, they can create it, but the network and storage and backend functionalities, firewall, they cannot manage. They can just only manage the application. And OpenShift, Cloud Foundry is and IBM Bluemix. Those are very good examples. And OpenShift is now and Cloud Foundry is a pioneer in the PaaS solution in the cloud. So almost 100,000 of plus applications are hosted right now on that OpenShift PaaS solution. And there is another cloud solution that is called SaaS. So SaaS is basically, I would say, you have you have an application, you publish that application over the internet. So application in the sense, the application kind of where you can manage your infrastructure, and like can say is a Gmail. Gmail is a kind of a SaaS solution, and I think you heard about Open 365, Open Office 365, Microsoft new product. Did you heard about it?
Yeah, I do. I do know about that one.
You know?
1 second.
Okay.
Can you hear my voice?
Yes, I can hear you.
Yeah, it's showing and it's unmuted still. That's why I thought it is unmuted. Yeah, I do hear about Office 365.
Okay. So what is Office 365? You can manage the VM, and you can you can manage your email accounts, and they provide some storage as well, right?
Yeah, I do remember. Yes.
Yes, they provide some. So basically, that is a SaaS solution.
Oh,
So SaaS is basically you have an application, you publish the application. The application is a kind of enterprise application. It's not like that you have just a website. Enterprise application published over the cloud, so you can manage your resources, you can manage your database. So you can access like a Salesforce is one of the best example of the SaaS solution. They provide a CRM. So Salesforce is the number one CRM company in the world, and they provide a SaaS solution for the CRMs. So there's a different kind of uh, cloud technologies, cloud models are there. The IaaS, infrastructure as a service, PaaS, platform as a service, SaaS, software as a service. So when we'll go through the training, I will cover up in detail how exactly those work. What are exactly these cloud models and what service we offer in these cloud models. And apart from that, the OpenStack is based on a IaaS, infrastructure as a service. So there you can manage your network, you can manage your storage, you can manage your compute. Systems. You can manage your VM, you can manage your firewall, each and everything. Whatever the component you have in your data center, you can manage your in OpenStack Cloud. So OpenStack Cloud is basically completely it is developed in a Python and runs on a Linux kernel, and the tested first of all, yes. So without virtualization, there is no cloud. So virtualization technology is the backbone of the cloud. So OpenStack, majorly it's OpenStack tested on a KVM hypervisor. So we will cover up KVM as well. Before go to the OpenStack, we will cover up KVM, how exactly KVM works, what is the functionality of KVM, how we create, if suppose there is no OpenStack, just only the virtualization, how we can create the VMs into the KVM, how we can manage the CPU memory of the VMs into the KVM virtualization. So first we will cover up KVM. And OpenStack also gives functionality to manage other resources, and we can say other virtualization to manage and work with other virtualization technologies like VMware, Hyper-V, Zen, and the new thing is Linux container Docker. It also supports Docker. So this is the basic, of the OpenStack cloud. So OpenStack basically, I think it's you can manage your entire data center, and first of all, it gives you flexibility to manage the resources very fast. You can load sharing, and definitely in a normal, if we have a physical system and you're running application, then 80% of scenarios, this has been observed that only the 20 to 30% resource are in use in the physical server. If you have 20 GB memory, it's only 4 GB memory used. Definitely, it depends on the workload. So basically, what virtualization technologies give? So virtualization technology gives our better utilization, optimization of the hardware resources. If you have a physical server, you can run only one operating system and one or two or three application in a physical server. And definitely the compatibility of the, if you are running multiple applications into a single system, you need to check compatibility of the libraries, each and every component you need to check. However, virtualization give you flexibility. On a single system you can run n number of virtual with a different operating system, Windows, Linux, and you can definitely if you have a different kind of operating system on a single system, you can run n number of VMs, n number of application into that operating system, and the performance and the features is almost same. So basically, first of all, and the application, and so usually OpenStack Cloud is basically any cloud solution is basically for the applications. It's not. So we can, whenever we want, we can create the application, we can manage the application. It provides the, complete flexibility and can say, resource optimization, facility of the resources. So I think I know your, you, the OpenStack Cloud. So might be some part you could not get it properly, but if you have any question, you can ask me. And Pawan, are you there? Okay.
Yeah, now I can hear your voice.
Okay, I think you
I,
missed my part. Okay, no problem.
yeah, that's what
Okay,
I
no problem.
understand. Trying to do.
Mm-hmm. So, okay, so fine. So, as I said, I think you got my point. There's a what are the major three cloud models in the market? It's the IaaS, PaaS, and SaaS, right?
Okay.
And so I think I explained that. Did you hear that, or I mean topic?
Yeah, I
I
heard up
can.
to the what you are saying about KVM virtualization.
Oh, okay, right. So yes, so so as I said, so there is an if the virtualization technology is the backbone of the cloud technology. If suppose there is no virtualization, no cloud. So if we work on the cloud technology, whether it's any solution, whether it's Amazon basically they use a Zen hypervisor in that IaaS solution. So OpenStack majorly developed and tested and deployed. I worked in a production center, one of my client. So they deployed KVM for the OpenStack cloud. So KVM is basically provides a functionality and developed, I mean, with the complete flexibility and compatibility with the Linux kernel. So whatever features we can get with the Linux operating system, the same features we can apply it and we can test and we can deploy into the KVM virtual machines. From what am I audible to you?
Yeah, yeah, I can hear you.
Okay. So after that, I'll do one thing. I'll show you a better. I'll show you some document. So you might have a better picture on that. Okay. Okay. Let's take this. So OpenStack is basically there are different projects. Compute. The major projects are compute. Means we can say physical servers, virtual or virtual servers. Networking is a networking stack, whether it's a switch, whether it's a router, and firewall, load balancer, and storage. There is another stack called storage. So storage in the storage we can manage images, virtual machine images. We can manage the volumes, and we can manage object-based storage. So basically there are two types of storage basically. First is object-based storage. Second is a block-based storage. So in the block-based storage, we get the raw volume into the VM. We can format that VM. We can make our file system. We can keep our data on that. However, the object-based storage, the file system is already there. We can just put the raw material, raw data, unstructured data, like very big companies like Facebook, Twitter, and LinkedIn. They use object-based storage because there are lots of, I mean, images, files, lots of unstructured data. I mean, people upload on the website, so they need some solution. So basically, they use object-based storage. So in the OpenStack, we can manage our data center on the cloud, where there's any component of the data center we can manage. And there's majorly there are two kind of cloud: public and private. Now, what is the public? Public definitely is we can buy cloud services from the cloud service providers like Amazon, Rackspace, and now I think IBM. They are also in the market right now. So that is a public cloud. However, what is a private cloud? So private clouds is you can deploy the cloud solution in your own data center in the office premises across the geographical locations. So basically, that is not published over the internet. So basically, it is a public private cloud. You just deploy that cloud inside data center. So public cloud is the companies they provide a public cloud solution for the internet like Amazon, and there's a different another cloud that is called hybrid cloud. So hybrid cloud is a mix of private and a public cloud. So whenever is required, the solution must be like that. Whenever is required, user application can move from public to private, private to public cloud, just based on the user requirement. So basically, that is a hybrid cloud.
Okay.
So what problem does OpenStack solve? OpenStack provides a framework to build elastic cloud infrastructure at massive scale, right? So let's take example. I'll give you an example. Uh, you are a administrator and you are a virtualization expert guy. You have a physical system. So in a virtualization, there is a certain limit that in a physical system we can run only the definitely if suppose we are going to install operating system on a physical system directly we will have only one operating system, right?
Yeah, yeah, okay.
And in a virtualization we can create a number of VMs, right, on a single operating system, right? But in a
Yeah, yeah. In
virtualization also
virtualization, we can.
yeah, so but in a virtualization also we have a limit. If the system must have a, I mean, certain limit with the memory, with the compute, and with the processor, so we can create only certain number of VMs in a physical server. However, what OpenStack does, horizontally you can add your virtualization host, so user will never come to know where exactly my VM is hosted. No user will not be worried about that where my machine going, whether the next I mean the compute system has enough capacity or not. Whenever required, OpenStack manages a number of virtualization servers. There is no limit. You can just horizontally add and you can work. Network. So basically, what it does. So basically, OpenStack uses SDN, software defined networking. There you can manage switches, routers at the software layer. So whenever you want, you can delete a switch because it's a software switch. Whenever you want, you can delete a router. Whenever you want, you can create. Just click it, give the subnet information, give the gateway information, switch is created, and it provides all same functionality, same rules, and same security as the physical switch. And definitely the high availability is also there. So basically network in OpenStack they use Neutron. So Neutron is based on SDN, software defined networking, where each and every component of the network can be managed at the software layer. Storage, so same as the storage resources. So definitely let's take example. In a data center you have a one physical server, right? And you have a one storage, one single storage box, SAN storage, and that SAN storage has 40 TB of capacity, storage capacity. What if that 40 TB is completely used? What you will do? You need to buy a new storage, and
Yeah.
that is going to take lots of time, lots of I mean
Investment.
human work and configuration. Definitely that I mean power cost is there, electricity cost is there, and shipping cost is involved in that. And after that, you cannot stack two different switches together. Suppose you have one EMC storage, and just because of cost, you buy different Hitachi storage. Now the problem is this storage is full, and you have new storage in your data center. You cannot stack those two storage boxes together. They cannot work together. So that is another problem. So OpenStack solves that problem. The storage can be managed completely at the software layer. So whatever the backend, whatever different kind of vendor uses at the software layer, no problem. The same. So basically, the what OpenStack does and cloud does, it provides the flexibility to choose any vendor in your data center. There is no such lock-in that if you are using HP, then you need to the next system you have to buy only HP. It's not like that. You can buy any system. And provides a natural infrastructure for elastic applications. So where, as I told you, whenever you want, you can just scale up, scale down the infrastructure, and there's a orchestration, automation is also there in OpenStack. So just write the code, automation code, push that code, it will create VMs applications for you. So next thing is, okay, So these are the main core components of the OpenStack. So actually these are different 9 projects. Those are bundled together. After that, OpenStack comes into the form. So identity, what identity does? Identity provides the authentication service, whether it's for the application, whether it's for the users or tenants. And the project name is a Keystone. So Keystone is the identity service that manages authentication, passwords, and all of the communication mechanism comes into the picture. So dashboard is nothing, that is a GUI. So you can access from the browser. No, and the best thing is OpenStack, whatever you can do, GUI you can do from the command line in OpenStack. Orchestration, so the project name is a heat. So in the identity, the project name is a Keystone. Dashboard, project name is a Horizon. So it just gives you the web dashboard. You can manage your resources from the web portal. Orchestration, project name is Heat. So basically that is a automation. You can just push your code into a project. It will work for you. Metering, basically that is for the project name is a Ceilometer. So basically what is done is calculate the cost for the customer. Suppose you are a cloud service provider. I'm a customer. I'm using a cloud solution. So whatever the resources I'm using in your cloud solution, whether it's a storage, it's a network, or it's a compute, it will calculate the resource utilization. Based on that, you can calculate the cost for the particular user. So object storage, as I told you, is object storage is a storage where we can keep raw unstructured data like images and videos, kind of unstructured data. So an image service, basically image service provide a solution where you can keep your virtual machine images and ISO images. So whenever required, just select the image, boot your new VM. Block storage, it provides the storage bus solution so that you can add a raw volume into the VM, and you can increase the size of your operating system. Networking stack, the project name is Neutron. Provide a complete networking solution. It's based on SDN, and this I think that SDN developed by OpenFlow. OpenFlow is an open source company, and SDN stands for the software defined networking. Compute is a project name is Nova. So compute is basically hypervisor technology, where there is any hypervisor, KVM, VMware, Hyper-V, Zen. So here in the next slide, it reflects the project name is the Keystone. So these are different features of the Keystone. How exactly, what are the components of the Keystone? How exactly those works together? And after that, there's a Horizon. So basically, this gives you dashboard, log in and manage the resources. So next is a Heat. This provides orchestration, automation. You can just keep the templates over there. You can write the code. You can put template over there. Just click on that. It will launch the application or VM, anything, whatever you put it into the code. So, and definitely there is a how exactly they works together. That is a different case that will explain you each and everything, how exactly these components work together. What is the request flow? Whenever we create a VM, what are the components that affected, and how where exactly that how is the database updated? Each and everything I will cover up. So this is a metering. Project name is a Ceilometer. Swift. Project name is Swift, and the technology is open storage, object storage. Next is the Glance. Project name is Glance, and the product is Maze Services. Syndra, block storage. It provides snapshot functionality. Sorry, just one moment. Snapshot, backup, and volume. Whenever we want, we can create and delete the volume. Networking is provide a complete stack to manage the resources. Networking resources, network, router, switches, ports, firewall, load balancer is also there. And this is a not networking component. There's a different component that work together, and as the switch basically that is a layer 2 device and router is a layer 3 device. So how exactly those components work? So each and everything, whatever we can do in a physical data center network, we can do in a SDA Neutron. Last is Nova. Basically, there is a hypervisor. We can create a virtual machines. So this is different. I mean, when we boot a server, how exactly that works? This is the flow. So, and the last thing I would like to show you is the dashboard. If you go here, oh, I logged out. So when we'll start from basics of Linux, basics of KVM virtualization. After that, we'll go for the OpenStack. So here are the resources. I have a tenants project is a represents an organization or company, we can say. So and that when we do configuration, so that term is called tenants in OpenStack. You can see here, you can say resource utilization, hypervisors. So this is OpenStack basically, basics we can say. If you have any question, you can ask me.
Do we need any more programming on Python? Do we need any idea
No.
about that?
Yeah, so actually OpenStack basically written completely in a Python, but in OpenStack there are two kinds of jobs into market. Second is first is a developer, second is the administrators. I'm an administrator, so so no need to worry about the code. Definitely when we are administrator, we have experience. If anything fails, we can easily know what code is saying. So whenever it shows the error messages, so those error messages definitely comes from the Python APIs, but those are converted into the can say operating system kind of logs. So you can easily understand what exactly is failed. So that programming skills, I don't think so very much required.
Oh, okay.
It depends what kind of role you choose.
Okay, got it. That's it right now. Fine. Yeah, I'll just have the brief introduction of this on the online. I'll have study material.
Mm-hmm.
I'll let you know, okay?
Yeah, sure. No problem.
Thank you, Sundar.
Yeah, thanks, Mohan.
Yeah, thanks a lot. Bye.
Okay, bye.